What if I told you that right now, someone on your Wi-Fi network could be watching your phone screen, reading your messages, and accessing your entire gallery? And what if I told you it could all happen through one setting that's probably already enabled on your phone? Welcome back to Tech Sky. In today's eye-opening video, I'm going to show you exactly how attackers can gain complete control over an Android device through your local network, and, more importantly, how to protect yourself from becoming a victim. But before we dive in, I need to make something absolutely clear. Everything we're about to demonstrate today is purely for educational purposes. Using these techniques without explicit permission is not only unethical, but illegal. We're learning these methods to understand how attackers think and how to defend against them. All our demonstrations today will be performed in a controlled laboratory environment using virtual devices that we own and control. Today's video is going to be packed with detailed information, so grab your notebook. We're going to cover everything from setting up a testing environment to executing the attack and finally learning how to protect ourselves. Before we begin, you'll need a proper lab setup. I have a detailed video covering the complete Genymotion installation and configuration. You can watch it through the info card. But here's the quick overview. Download Genymotion from the official website. If you already have VirtualBox installed, choose the version without VirtualBox bundled. Otherwise, download the package that includes it. Install Genymotion, then create a free personal account or log in if you already have one. Create an Android virtual machine. I recommend Android 12 as it represents a middle ground between older and newer devices, but you can test multiple versions if you want comprehensive coverage. Network configuration is critical. Both your Android virtual machine and Kali Linux must be on the same network. My Android 12 VM has two network adapters. The first is host-only adapter number 2 for internal lab communication. The second is NAT for internet access. My Kali machine uses the identical network configuration. This setup simulates an attacker and victim on the same Wi-Fi network. Now let's begin the actual exploitation. Switch to your Kali Linux machine. Open a terminal. Before installing anything, update your system. Type sudo apt update to refresh package repositories. Once that completes, type sudo apt upgrade to install available updates. Now we need to install the required tools. Type sudo apt install adb and press enter. When prompted, press Y to confirm. ADB is the Android debug bridge client that allows us to communicate with Android devices. Once that installation finishes, type sudo apt install scrcpy. This tool provides the screen mirroring capability we'll use later. Next, we'll install PhoneSploit Pro. Open your web browser. In the address bar, type github.com/techsky-code and press enter. Click the Repositories tab. You'll see PhoneSploit Pro listed. I've forked this project and fixed some minor issues to ensure a smooth experience. You can read the complete documentation, but I'll demonstrate everything step by step. Copy the repository URL. Back in your terminal, type git clone and paste it. Press enter and wait for the cloning process to complete. Once finished, navigate into the directory by typing cd PhoneSploit-pro. Type ls to see the contents. Several files and folders appear, but two are important right now. Requirements.txt contains all the Python dependencies we need. PhoneSploitPro.py is the main tool. We'll set up a Python virtual environment to keep everything isolated. Type python 3-m venv.venv and press enter. This creates a virtual environment. Activate it by typing source.venv/bin/activate. Your prompt changes slightly, indicating you're now working inside the virtual environment. Install the requirements by typing pip3 install-r requirements.txt. This downloads and installs all necessary Python libraries. Now run the tool. Type python 3 PhoneSploit.py and press enter. The main menu appears with multiple options. we'll explore the most impactful capabilities. Option 1 connects to the target device. Type 1 and press Enter. The tool asks for the target IP address. Switch to your Android virtual machine. Look at the top of the window. The IP address is displayed there. If you're using a physical testing device, find the IP address in Settings under Network or About Phone. But the IP address alone isn't enough. We need USB debugging enabled on the target. Open the phone settings. Scroll down and tap About Phone. Scroll until you see Build Number. Tap it 7 times rapidly. A message appears saying, "You are now a developer." This unlocks the hidden developer options menu. Go back to the main settings screen. Tap System. Scroll down and you'll see Developer Options. Tap it. The menu shows it's enabled. Scroll down further until you find USB debugging. Tap the toggle to enable it. A warning appears about security risks. This is exactly what we're exploiting. Confirm to enable it. Back in your Kali machine, type the target device IP address and press Enter. When asked to restart the ADB server, press Y. Watch what happens. The tool establishes a connection. A message confirms the target device is now connected. We now have complete remote access. Let's verify the connection. Type 2 and press Enter to list connected devices. Our Genymotion device appears in the list. The connection is active and ready for exploitation. Now for complete device control. Type 5 and press Enter. The tool asks about screen quality. Press 1 for the default best quality. Within seconds, a window opens showing the phone's screen in real time. This is full screen mirroring. I can tap, swipe, type, and interact with every app exactly as if I were holding the phone. Open apps, read messages, access photos, check banking apps. The victim sees nothing unusual on their end. The phone functions normally, but I'm watching and controlling everything remotely. Let me close the mirror window and continue testing other capabilities. Type 6 and press Enter to capture a screenshot. The tool grabs the current screen. When asked to open it, press Y. The screenshot appears, showing exactly what was on the victim's screen at that moment. Imagine an attacker timing this when you're entering passwords or viewing sensitive information. Next, screen recording. Type 7 and press Enter. The tool asks for duration. I'll type 5 and press Enter for a 5-second recording. Recording starts. Everything happening on the phone is being captured as video. When it finishes, I'll press N to skip automatic opening. Instead, navigate to the PhoneSploit Pro folder. Inside, you'll find a folder called Downloaded Files. Open it. Both the screenshot and screen recording are saved here. The attacker now has permanent records of your phone activity. Let's escalate further. Type 8 to download files or folders from the device. The tool shows the SD card path. I'll download the entire SD card directory. Press Y and Enter. Watch as the complete directory structure transfers to my machine. When prompted to open it, press Y. The entire phone's file system appears. Photos, documents, app data, everything stored on the device is now in the attacker's possession. Type 13 to see installed applications, then press 2 to view all apps. A complete list of package names appears. Every app installed on the phone is visible. Attackers use these package names to manipulate app behavior or extract app-specific data. Now for the most dangerous capability. Type 14 to access the device shell. This gives command line control over the Android operating system. You can execute any command as if you were sitting at a terminal inside the phone. Type getprop.ro.product.manufacturer and press Enter. It returns Genymotion, confirming the device details. Type ls-la/SD card/ to list its contents. The complete directory structure appears, including the screenshots and recordings we captured earlier. Type dump sys battery to view complete battery information. Charge level, voltage, temperature, health status, all exposed through shell access. Exit the shell by typing exit and pressing Enter. But there's more. Option 15 launches a Metasploit payload attack. I've covered this in detail in a previous video that reached over 1 million views. You can watch the complete tutorial through the info card. But here I'll demonstrate the automated version. Type 15 and press enter. Press enter again to continue. The tool asks for your local host and local port. I'll enter them manually, so press M to modify the default. Now open a new terminal. Type ifconfig to see your network interfaces. Find eth0 and copy the IP address. Switch back and paste it. For the local port, type 4444 and press enter. Press Y to continue. Watch what happens. PhoneSploit Pro automatically generates a malicious APK, transfers it to the target device, and installs it without any user interaction. On the phone side, the payload APK installs silently. On your side, a MeterPreter session establishes. When the session opens, you have post-exploitation access. Type sysinfo to view device information. Type getuid to see the server username. Type pwd to check the current directory. This level of access allows file manipulation, data exfiltration, persistence mechanisms, and complete device compromise. Type exit twice to close the MeterPreter session and return to the PhoneSploit Pro menu. We've covered the primary capabilities, but there are 4 more pages of options. Display photos on the device remotely. Listen through the microphone. Dump SMS messages. Restart applications. Uninstall apps. Change settings. The tool automates every aspect of ADB exploitation. So how do we protect ourselves from these types of attacks? Here are the essential steps every Android user should take. First, and most importantly, never enable USB debugging unless you're actively developing or testing applications. Most people enable it once for some app or tweak, then forget it's active. Go to your phone settings right now. Navigate to Developer Options. If it's enabled, disable it immediately. If USB debugging is turned on, turn it off. These settings should only be active during the specific moments you actually need them. Treat public Wi-Fi networks as hostile environments. Coffee shops, airports, hotels, any shared network could have an attacker scanning for exposed ADB connections. If you must use public Wi-Fi, disable developer options entirely before connecting. Better yet, use a reputable VPN that encrypts your network traffic and masks your device from local network scans. Always check what permissions you're enabling. When an app asks you to enable USB debugging, question why. Legitimate apps rarely require this level of system access. Keep your device updated. Many attacks exploit known vulnerabilities that are fixed in newer versions of Android. Those update notifications might be annoying, but they're crucial for security. Monitor your device for unusual behavior. Unexpected screen activity, apps opening on their own, or network traffic spikes could indicate unauthorized access. Android doesn't provide clear notifications when ADB connections establish, which is why prevention is critical. Regular security audits are important. Check your installed apps periodically, review your developer settings, and remove anything you don't use or don't remember installing. Finally, educate others. Most Android users have no idea USB debugging exists or what it enables. Share this knowledge with friends and family. A simple settings check could prevent your loved ones from becoming victims of remote exploitation. That concludes our demonstration for today. Remember, knowledge is power, but with that power comes responsibility. Use this information to protect yourself and others, never to cause harm. In our next video, we'll explore more advanced mobile security topics and how to harden your Android device against these types of attacks. If you found this video helpful, don't forget to like, subscribe, and hit that notification bell. Drop your questions in the comments below and let me know what security topics you'd like to see covered next. Until then, this is Tech Sky, your ultimate battleground of cybersecurity and ethical hacking. Stay curious, stay ethical, and keep learning.
上的爱是外界的爱是昨天的我的